Okay, this is exam review guide for second semester. And what I did is I went through the exam and I put into words what each question looked like. So we're going to jump right in. The first topic is systems of equations. And the first thing you're going to be asked to do is set up a system given a word problem. Okay, so the word problem may say, let me move this out of the way, may say something like this. A Workout Plus offers a membership for $30 a month plus a $100 startup fee. So Workout Plus offers a membership for $30 per month. So that's why we did 30M plus a $100 startup fee. FitWorks offers a membership for $50 each month plus a $20 setup fee. After how many months will the membership of both gyms cost the same? So the first question is just seeing if you can take the word scenario and come up with a system of two equations. And it's multiple choice, and you have to pick which system matches the word scenario. Okay. Second question is, can you identify the solution to a system if you're given a graph? So remember, when you have a system of equations, that means that it is two straight lines. And the solution is where those two lines intersect. So to identify the solution is going to be whatever the ordered pair of the intersection is. So I'm just going to make that up, and that would be our solution. Next question, solve a system of linear equations using the elimination method. So the elimination method is used when both equations are in standard form, meaning the x terms line up vertically, the y terms line up vertically, the equals, and the constants. So the idea of elimination method is you want to get these equations so that when you add them together, the variables cancel out. So right now, negative 2x plus 4x is going to be 2x. That's not going to be cancel out. 7y minus y is just 1y. That doesn't cancel. So what we want to do is, I notice that this bottom equation has a 4x. So if I could make the top equation have a negative 4x, I know that negative 4x plus 4x is going to cancel out. So what I'm going to do is I'm going to multiply this top equation through by positive 2. So 2 times negative 2x is negative 4x. 2 times 7y is 14y. And 2 times 13 is 26. I'm going to keep the bottom equation just as it is, because now when I add these two equations together, I can see that the negative 4x and the positive 4x are going to cancel out. 14y minus 6y is 8y, and 26 minus 2 is 24. Now I'm able to divide both sides by negative 8 to get y equals negative 3. 24 divided by negative 8 is negative 3. So I have half of my solution. Remember, a solution is an ordered pair. So I just found half of it. So to find the x value that goes with this, I am going to plug negative 3 back into any of these equations, any of the two originals or any of these. So I'm going to go down to this one just because I have more room to write. So 4x, I'm going to substitute negative 3 in place of y. So negative 6 times negative 3 is positive 18. Now to solve this equation, I subtract 18 from both sides and divide both sides by 4. So x is equal to negative 5. Okay, so that is the elimination method if you want to on Google and find some problems to try on your own. Okay, the next section is systems of linear inequalities. So as a review, when we have an inequality, it might look like this. Y is greater than 2x minus 3. And what we do is we imagine that this was an equal sign for a minute and we graph this line. So this line has a y-intercept of -3, and we rise to run 1, rise to run 1. So I'm just kind of rough sketching this. And now we draw our boundary line, and we draw our boundary line based on this symbol. And since it is just greater than, this is going to be a dashed boundary line. If it were greater than or equal to, it would be a solid boundary line. Now, when it's y is greater than, when it's solved for y, that means we're going to shade above the line. Another way to do this is you pick a test point. So if you pick 0, 0, do you see that 0, 0 is clearly above the line? So if I put 0 in for y and 0 in for x, I want to decide if this is a true statement. So is 0 greater? 2 times 0 is 0 minus 3. Is 0 greater than -3? Yes, it is. So we shade above the line to include our test point. If our test point made a false statement, that means it would not be in the solution set, and we would shade it down here. Okay, so you will have a system of 2 linear inequalities graphed, and you have to match which graph matches it. So I'm going to do this one. So let's say that our first equation is the one we just graphed. You would look for this line. You'd be looking for a dashed line, and you would find it. Then you would graph this line. So this inequality starts at +5. It's got a negative slope, so it's going downward. And because the inequality is less than or equal to, our boundary line is going to be solid, not dashed. And since its y is less than or equal to, I'm shading below. So our solution is the place where both of these shaded regions intersect. So this is what you'll be given on the exam, and you have to pick multiple choice the correct graph that matches the given system. Okay, next thing is simplifying rational exponents. So as a review, when you have a fraction in the exponent, that really means the denominator is the root. So this would mean the cube root of 8 to the first power. Okay, so if we did 4 to the 3/2 power, that would mean the denominator is the root. So that means square root. And when it's square root, you don't need any number up here because it's assumed to be a 2. So square root of 4 cubed. Okay, so you might see something like this. X to the 5/4 power is going to be the 4th root of x to the 5th. Okay, so you will have to go back and forth for these. If I give you it in radical form, like the 6th root of x to the 7th, you need to be able to go to fraction or rational form. So the base is x. The index of the root is the denominator, and this power is the numerator. Okay. All right, this next one we did early in the year, and then we've done it most recently. And this is where you need to understand and memorize these perfect square numbers, because we are going to use these perfect square numbers to simplify a radical. So there's the first 12. Okay, so we're going to take something like the square root of 150. And we're going to start going through and deciding which is the biggest number in this list that's a factor of 150. and I believe it's 25. So 150 is the same as 25 times 6. So we break it down here. Now we actually compute what this equals. Square root of 25 is 5. So we drop the square root sign. Square root of 25 equals 5. Square root of 6, we still can't simplify, so we leave the answer like this. Okay? Now sometimes there will be a number out front. So let's say that we have 5 times the square root of 32. And we need to simplify it. We're just going to ignore the 5 because that's all set. But we're going to break the square root of 32 down into factors. And we're going to try to find the biggest number in this list that's a factor of 32. So I notice that 16 times 2 is 32. So the square root of 16 times the square root of 2 is here. Now I go one step further. 5 is just our plain number. But the square root of 16 I can actually figure out as an integer. The square root of 16 is 4. Square root of 2, I still don't know, so it's going to stay here. So I'm going to combine this factor of 4 times the factor of 5, and my answer is going to be 20 square root of 2. Okay? All right, and it looks like this is just a duplicate of here. So change an expression from radical form to rational function form. So something like this, or something like this. So rational form would look like this, and radical form would look like this. Okay, that is your first page. Please continue with the remaining videos to work through our review.